76 days. That's how long you have until everything changes. While everyone else is celebrating New Year's Eve, toasting to the end of the year of the comet, thinking the show is over, 3i Atlas is accelerating toward Jupiter at 40 kilometers per second, and it's not slowing down. Before we go any further, I need to show you three things, three pieces of data that NASA has confirmed but not explained. First, the gravel cloud, 10 micron particles, magnetically active, currently settling into Earth's atmosphere. Second, the blue shift. The object is glowing blue despite moving away from the sun. That shouldn't be possible. Third, the trajectory. 3i Atlas doesn't need Jupiter's gravity to leave the solar system. It's already moving at hyperbolic velocity. So why is it going there? If you're watching this right now, you need to understand something. 2025 wasn't the main event. It was the setup. And what happens on March 16th, 2026, at Jupiter, is going to determine whether we're alone in this solar system or whether we're being catalogued. Make sure you're subscribed and notifications are on. The next 76 days are going to rewrite everything we thought we knew about interstellar objects. You need to be here for every update, because I'm not talking about rocks anymore, I'm talking about what comes next. Let's start with what's falling on your roof right now. In my last video, I showed you the data on the gravel cloud. The dust trail from 3i Atlas isn't behaving like comet dust. According to Dr. Avi Loeb's team at Harvard, the particle size is concentrated around 10 microns. That's large for cometary dust. Normal comet tails produce particles measured in fractions of a micron, the kind that burn up instantly in Earth's atmosphere. But 10 micron particles? Those survive re-entry. And here's where it gets interesting. Since that video dropped, my inbox has been flooded with observations. People in the southern hemisphere sending dashboard camera footage of slow-moving meteors. Amateur astronomers finding magnetic dust on collection plates that doesn't match terrestrial samples. Independent analysis from the International Meteor Organization confirms something NASA hasn't addressed yet. The size distribution is anomalous. In nature, when you break a rock, you get chaos. Big chunks, small chunks, dust, boulders. It follows a power law distribution. But 3i Atlas is leaving behind particles that cluster around a very specific size range, too uniform for random fragmentation. Dr. Loeb published a paper in the Astrophysical Journal Letters last month pointing out this uniformity. His exact words, "The narrow size distribution suggests a controlled release mechanism rather than chaotic ablation." Controlled release. Think about what that means. When a farmer plants seeds, the seeds are identical. Same size, same mass, same genetic payload. Each one is designed to survive the fall and activate when conditions are right. The dust shield that 3i Atlas deployed, the one that created optical depth equals 1, it wasn't just hiding the object. It was a precisely calculated drop. We're currently passing through the wake of that deployment. The heavy particles are settling into Earth's upper atmosphere. They're not burning up, they're landing, and we have no idea what they're made of. But here's the most interesting part. That optical depth value. Optical depth equals 1, not 0.9, not 1.1, exactly 1. For anyone who doesn't work in atmospheric physics, optical depth is the measure of how much light gets through a cloud. If optical depth is too low, say 0.5, the cloud is transparent. You see right through it. If optical depth is too high, say 2.0, it's opaque. Complete blackout. But optical depth equals 1. That's the Goldilocks value. It's the exact threshold where light dims but doesn't disappear. It's the perfect balance for a cloud that needs to obscure something while still being detectable. Think about what has to align for that to happen naturally. Particle size, particle density, cloud thickness. 3 independent variables all converging on the same precise value. The odds of that happening by chance? You might as well flip a coin 100 times and get 100 heads. Possible? Technically? Natural? That's the question. Now you might be thinking, optical depth equals 1 could just be a coincidence. Some number has to come up, and that's fair. I'm not dismissing that. But here's what that natural explanation requires. You need the ice sublimation rate to produce exactly the right particle flux. You need the solar wind pressure to compact that flux into exactly the right density. You need the object's rotation to spread it into exactly the right geometry. Those aren't just 3 coincidences. Those are 3 precisely calibrated mechanisms working in perfect synchronization, which requires less faith that nature randomly hit the engineering sweet spot, or that something calculated it. Let's talk about the dust composition. A team at the European Southern Observatory ran spectroscopic analysis on the tail material. They found nickel. Not trace amounts, significant concentrations. Now, nickel isn't unusual in comets, but here's the problem. Nickel and iron are chemically bonded in space. They form the cores of asteroids together. They fall to Earth together in meteorites. They're inseparable twins, except in 3I Atlas. We see the nickel. But the iron to nickel ratio is inverted. It's 1,000 to 1 in favour of nickel. Dr. Loeb called it chemically bizarre in his Archive preprint. In nature, you don't separate nickel from iron. The melting points are too close. The chemical affinity is too strong, unless you have a refining process. Unless you're selectively releasing one element while retaining another. Industrial chemistry, metallurgy. Those are engineering terms, not geological terms, but the dust is just the residue. The main unit, the object itself, is moving on, and this is where the mainstream narrative starts to crack. NASA says 3I Atlas is using Jupiter for a gravity assist, a slingshot maneuver to pick up speed and leave the solar system. We do it all the time with our probes. Voyager, Cassini, New Horizons. You steal momentum from a planet to accelerate. Standard orbital mechanics. Except here's the problem. 3I Atlas doesn't need it. The object is already moving at hyperbolic velocity. That means it has enough speed to escape the sun's gravity well. It can leave the solar system right now, today, without any help. So why is it going to Jupiter? It's going out of its way. The trajectory correction required to intercept Jupiter adds weeks to the journey. It exposes the object to massive radiation. Jupiter's magnetosphere is a nightmare. A plasma torus that fries unshielded electronics in milliseconds. If you're a rock, you don't care. Rocks don't have circuits. But if you're a machine, you avoid Jupiter unless you have a very specific reason to be there. There are two possibilities. First, power. Jupiter is a natural dynamo. The magnetic field generates terawatts of energy. If you have the right equipment, a magnetic tether or an induction coil, you can harvest that power. You can recharge your batteries after a 1,000-year cruise through interstellar space. Think about the Voyager probes. After 40 years, they're running out of juice. Their plutonium generators are decaying. They're shutting down instruments one by one to conserve power. A probe crossing light years would face the same problem, unless it planned a refueling stop. Second possibility, communication. Interstellar distances are vast. A small probe, less than 1 kilometre wide, can't carry a transmitter powerful enough to shout across the galaxy. The signal would dissipate into noise before it reached the next star, unless you use an amplifier. Jupiter produces decometric radio emissions. It's the loudest radio source in our sky after the Sun. Those emissions are caused by interactions between Jupiter's magnetic field and its moon Io. They create bursts of radio energy that can be detected from Earth with amateur equipment. If you modulate that signal, if you use the planet itself as a carrier wave, you can send a data packet that will propagate for light years. On March 16, 2026, 3I Atlas reaches Perigove, the point of closest approach, the optimal alignment for that kind of transmission. Now, I'm not saying this is definitive, I'm not saying it's proven, but the timing is suspicious. The object spent a month scanning Earth from December into January. It collected atmospheric data, surface temperature readings, possibly even radio leakage from our satellites and broadcasts. If it's carrying that data, March 16th is the upload window. After that, Jupiter moves out of alignment. The next opportunity wouldn't come for years. It's now or never. While everyone was focused on the dust cloud, something else happened that didn't get much attention. The blue shift. As 3I Atlas moved away from the Sun after perihelion, it should have cooled down. It should have faded into the infrared spectrum. That's basic thermodynamics. But telescope data from amateur astronomy networks shows the object is maintaining a persistent emission in the blue wavelength. NASA's explanation? Fluorescence. Carbon monoxide reacting to sunlight. And that makes sense for a normal comet. Except the intensity isn't dropping. The Sun is getting farther away every second. The UV flux hitting the object is decreasing. The fluorescence should be fading, but it's not. The blue glow is constant. There's another explanation. Cherenkov radiation. That's the blue glow you see in nuclear reactor cooling pools. It happens when charged particles move faster than the speed of light in a medium. It's a signature of high-energy particle beams. We could be seeing the exhaust of a propulsion system. Electric thrust. Ion drive. something that accelerates particles to relativistic speeds. And here's why that matters. The object is exhibiting non-gravitational acceleration. That's been confirmed by multiple observatories. It's moving faster than gravity alone can explain. The standard explanation for comets is outgassing. Jets of sublimating ice create thrust like a rocket. But 3I Atlas is accelerating away from the Sun, where temperatures are dropping. Outgassing should be slowing down, not speeding up, unless it's not outgassing, unless it's thrust. And there's the rotation, that perfect metronomic 7.74-hour spin period. Dr. Loeb's team noted it in their analysis. It's too stable for a tumbling object. Natural rotation is chaotic. You get wobbles, precession, variations in period. But 3I Atlas rotates like a clock. That kind of stability suggests spin stabilization. It's a technique we use in spacecraft design. You spin the craft to maintain orientation during a burn. The gyroscopic effect keeps the thrust vector aligned. If 3I Atlas is firing a propulsion system, that 7.74-hour rotation makes sense. It's not tumbling, it's orienting, pointing. The object is accelerating toward Jupiter on purpose. It has a window to catch, and it's not going to miss it. So what does this mean for us? What does 2026 look like? If 2025 was the year of discovery, 2026 is the year of consequence. I'm going to make 3 predictions, things you can watch for over the next 76 days. First, atmospheric effects. The dust veil from 3I Atlas is spreading in Earth's upper atmosphere. We're already seeing anomalies, noctilucent clouds appearing at unusual latitudes. These are ice crystal clouds that form at the edge of space, around 80 kilometers up. They're normally confined to polar regions, but observers in mid-latitudes have been reporting them since December. The International Space Station photographed them over North America last week. That shouldn't be happening. The dust is seeding ice formation at altitudes where water vapor is normally too sparse. We might also see effects on satellite communications, GPS drift, radio interference, Starlink outages. The gravel cloud is electrically conductive. It could create plasma instabilities in the ionosphere. Keep an eye on space weather reports in January and February. If you start seeing unexplained satellite failures, that's a data point. Second prediction, radio anomalies from Jupiter. Around mid-March, specifically March 15th through 17th, monitor the news for reports about the Juno spacecraft. Juno is NASA's probe currently orbiting Jupiter. It's been studying the planet's atmosphere and magnetic field since 2016. If 3I Atlas interacts with Jupiter's magnetosphere, Juno will detect it. Watch for stories about unexpected magnetic field fluctuations or instrument malfunctions. Also keep an ear on amateur radio astronomy networks. Jupiter's decometric emissions can be detected with shortwave equipment. If there's a modulated signal, if there's a data burst embedded in those emissions, the amateur community will catch it before NASA says anything publicly. I'll be monitoring those channels. If something happens, you'll hear about it here first. Third prediction, activity at the L2 Lagrange point. For those unfamiliar, L2 is a gravitationally stable point in space, about 1 million miles from Earth. It's where the James Webb Space Telescope is stationed. It's the perfect location for a long-term observer. No orbital decay, minimal fuel requirements. If 3I Atlas deployed a secondary probe, a smaller unit designed to monitor Earth, L2 is where you'd put it. Now, here's what to watch for. NASA recently announced unexpected maintenance operations for Webb in Q1 2026. They're planning to adjust the telescope's orbit. Why? Webb was designed to operate at L2 for 10 years without major adjustments. What changed? Also watch for new satellite launches targeting L2. If you see commercial or government payloads heading to that region, especially with vague mission descriptions, that's worth noting. Something might be there, and someone might be going to look at it. Now the skeptics will say, if it's alien technology, why didn't it land? Why didn't it make contact? Why didn't it do anything? And that's a valid question. But it assumes alien intelligence would behave like us. We're loud, we're aggressive, we announce ourselves, we plant flags. But a civilization capable of interstellar travel? They might have different priorities. Think about how we study wildlife. We don't land a helicopter in the middle of the forest and introduce ourselves to the deer. We observe, we tag, we collect data, we leave remote sensors, we avoid contaminating the ecosystem, A sufficiently advanced civilization might treat us the same way, not as equals to communicate with, but as subjects to study. The fact that 3i Atlas ignored us might be the most significant thing about it. You don't ignore a threat, you ignore something that's not ready yet, or something that's already catalogued. There's a concept in astrobiology called the zoo hypothesis. It suggests that intelligent life is common in the galaxy, but advanced civilizations deliberately avoid contact with less developed ones, not out of hostility, but out of policy. Like a wildlife preserve. We're the animals in the zoo and they're the visitors watching from outside the fence. We can't see them because they don't want to be seen, but they see us. They've always seen us. 3i Atlas might be a periodic inspection, a routine check-in to see if we've developed anything interesting since the last visit. And maybe this time we have. Maybe our nuclear tests, our radio transmissions, our satellites finally made enough noise to warrant a closer look. And now that the inspection is complete, the report is being sent back. Yes, they've split the atom. Yes, they've reached orbit. No, they're not a threat yet. Continue monitoring. Let's talk about the Fermi paradox for a second. Where is everybody? We've been listening for radio signals since the 1960s. 60 years of scanning the sky for alien broadcasts, and we've heard nothing. Silence. That silence has led many scientists to conclude we're alone, or at least very rare. But what if the silence just means we're looking for the wrong thing? Radio waves spread out. They get weaker with distance. They're easy to intercept. If you're trying to communicate across the galaxy, radio is inefficient and insecure. But physical probes don't spread out. They go exactly where you send them. They carry massive amounts of data on solid-state memory. They're high bandwidth, high latency communication, the sneaker net of the cosmos. Maybe we haven't heard them because they're not broadcasting. Maybe they're networking, sending hard drives back and forth across the stars, and we're not on the network. We're just the subject of a data packet that's about to be delivered. Here's the timeline. Oumuamua in 2017. The first confirmed interstellar object. Tumbling, accelerating, gone before we got a good look. 2i Borisov in 2019. The second, a normal-looking comet. Reassuring. It told us interstellar objects are just rocks. And now, 3i Atlas. Stranger than Oumuamua. More active than Borisov. A combination of both. The frequency is increasing. 8 years between nothing and the first, 2 years to the second, 6 years to the third. The intervals are irregular, but the trend is clear. They're coming more often. Why? Is it statistical noise? Just the randomness of cosmic billiards? Or is it something else? Is the network waking up? Are we approaching a threshold? A deadline? We don't know. But March 16th might give us a clue. I want to address something. Some of you are going to watch this and think it's fear-mongering, that I'm selling paranoia, that I'm turning cosmic dust into existential threats for views, and I understand that. Skepticism is healthy. But here's what I'm actually doing. I'm pointing at publicly available data that doesn't fit the standard model. I'm asking questions that aren't being asked in mainstream channels. The dust size distribution? That's real. Dr. Loeb's papers? Published and peer-reviewed. The blue shift? Confirmed by multiple observatories. The trajectory to Jupiter? NASA's own orbital data. None of this is made up. None of this is fringe science. These are observations, and observations demand explanations. The official explanation is, it's a comet. Fine. But comets don't release uniform particle sizes. Comets don't maintain constant blue emissions while moving away from heat sources. Comets don't detour to radiation-filled magnetospheres when they're already fast enough to leave. So either our understanding of comets is wrong, or 3i Atlas isn't a typical comet. Both possibilities are worth exploring. That's not fear-mongering, that's science. Here's what I want you to do. Over the next 76 days, pay attention. Watch the sky. Monitor the news. Not mainstream news, that's lagging and filtered. Watch amateur astronomy networks. Reddit. X. Independent science blogs. The data flows faster there. If something happens at Jupiter in mid-March, if there's a radio burst or a magnetic anomaly or an unexpected signal, you'll hear about it in those channels first. And when you do, come back here. We'll analyze it together. Because this channel is building something. We're creating a distributed observatory. A community of people who ask questions that institutions won't ask. Not because those questions are crazy, but because those questions are uncomfortable. They challenge assumptions, they threaten funding, They open doors that some people want to keep closed. We're opening those doors. And whatever's on the other side, we'll face it together. March 16th is the node. It's the moment when 3i Atlas reaches Jupiter and either does something or doesn't. If nothing happens, if it just flies by like a rock and keeps going, then we were wrong. The data didn't mean what we thought. And that's fine. Being wrong is part of science. But if something does happen, if there's a signal or a transmission or an event that can't be explained away, then everything changes. The question of whether we're alone gets an answer. And that answer is no. We are not alone. We never were. We were just too loud and too arrogant to notice the observers taking notes from the edge of the playground. 2026 is going to be a remarkable year. Not because the world is ending, not because aliens are invading, but because we're finally asking the right questions. We're finally looking at the data without bias, without the need to conform to a narrative. The narrative is, space is empty, we're alone, comets are rocks. But the data says, space is busy, we're being watched, and some rocks are smarter than we are. Which do you trust? The narrative or the data? I'm going with the data. Let me give you one more number to think about. The local standard of rest velocity. When 3i Atlas entered our solar system, astronomers calculated its velocity relative to the Sun, standard procedure. But Dr. Loeb's team also calculated its velocity relative to the local standard of rest. That's the average velocity of stars in our galactic neighborhood. Most interstellar objects have high LSR velocities because space is chaotic. Everything's moving in different directions at high speeds, but 3i Atlas, its LSR velocity was low, very low. It was almost stationary relative to the galactic frame before our solar system ran into it. Think about what that means. If you're a rock ejected from another star system, you inherit that star's motion. You come screaming through space at tens of kilometers per second relative to the galactic background. But if you're a probe designed to intercept passing star systems, you park yourself in the LSR frame. You become a buoy, a beacon, you wait. And when a star system like ours comes close, you wake up, you activate, you adjust course and investigate. That's what the data suggests. Not a rock randomly tumbling through space, but a platform deliberately positioned in our path. The activity started at 5 AU. That's the orbital distance of Jupiter. 3i Atlas began outgassing at 5 AU on the inbound leg. Why is that significant? 5 AU is the frost line for water ice. It's where temperatures drop low enough for water to freeze. But we already know 3i Atlas doesn't operate on water ice. It runs on carbon monoxide and carbon dioxide. Those freeze at much greater distances. So why wake up at 5 AU? Here's one possibility. 5 AU is the standard detection range for a passive biosignature scanner. If you're looking for oxygen in a planet's atmosphere, 5 AU is where you'd start getting clear spectroscopic data. Earth's atmosphere is 21% oxygen. That's a massive anomaly in a solar system full of carbon dioxide and methane. Oxygen is reactive. It doesn't last long unless something is producing it constantly, like photosynthesis, like life. A probe entering our system would detect Earth's oxygen signature at around 5 AU, and that's when it would wake up. That's when the mission would begin. Adjust course, release dust cloud for stealth, scan the biosphere, collect data, head to Jupiter for transmission. Mission complete. I don't expect you to believe all of this. I don't expect NASA to admit any of this. But I do expect you to think about it. Because the consequences of being right are far greater than the consequences of being wrong. If we're wrong, we wasted some time speculating about space dust. If we're right, we just witnessed first contact. Not the kind with handshakes and welcome ceremonies, the kind where we realize we're not the observers. We're the observed, and the observation is nearly complete. So here's my question for you. What do you think is happening here? Is 3i Atlas a rock? A comet behaving strangely because comets are weird? Or is it something else? Something that doesn't fit our models because it wasn't designed by nature? I'm not telling you what to think. I'm giving you the data and asking you to weigh the evidence. Natural explanation, 5 perfect coincidences that all align by chance. Artificial explanation, one designed system doing what it was built to do, which requires less faith. Drop a comment. Tell me what you think. I read every single one, and if you have a background in astrophysics, orbital mechanics, or atmospheric science, I especially want to hear from you. This community is building a knowledge base. We're pooling our expertise. We're becoming the distributed observatory that institutions refuse to be. Join us. I'll be tracking every development over the next 76 days, every data release, every orbital update, every atmospheric anomaly. If there's news, you'll see it here. If there's a signal on March 16th, we'll analyse it together. If there's nothing, we'll acknowledge that too. This isn't about being right. It's about being thorough. It's about asking questions in a world that's too comfortable with assumptions. Subscribe if you haven't already. Hit the notification bell. Share this with someone who's curious about what's really happening out there. Because whatever 3i Atlas is, it's the most important object to enter our solar system in recorded history. And we're about to find out why. March 16th, 2026. 76 days from now. Mark it. Watch it. Whatever happens at Jupiter, we'll be paying attention. Because the story isn't over. The story is just beginning. This is the year we find out if we're alone. And I don't think we are. I think we're being studied. And in 76 days, the study report gets filed. The question is, what does it say about us? And more importantly, what comes next? Stay curious. Keep looking up and keep asking the questions that make people uncomfortable. Because those are the questions that lead to truth. I'll see you in the next update.